Hello, class, and welcome to week one. Um, week one, we already went over an overview of Canvas, but week one, we're going to look at chapters 1 and 2, I believe. Yes, chapters 1 and 2, including Microsoft Windows and the threat landscape. So this course goes over Windows. I'll introduce some concepts of Linux and maybe a little bit of Mac as we go along. But all the exams and labs are in Windows, which is, Windows is commonly used across organizations now, especially for their LDAP services and SSO sign-on. Seems to be pretty much the standard. And then we'll also look at security in the Microsoft Windows operating system. And there's a couple of assignments this week. The plagiarism pledge, make sure that you do that and look forward to your graduate level writing. Go check this link. And we improve our writing and our speaking skills throughout our whole career. Looking forward to your introductions this week. I posted my introduction as well. And then the discussions this week is on the CIA Triad, which we'll go over a little bit in chapter 1, and then I'll give you the opportunity to do a little further research. So the discussions do provide you an opportunity to research the topic. Feel free to go down a tangent, introduce something to the class. Don't just regurgitate what's in the textbook, and that way we can have a more robust discussion. And I would rather see that, than just 20 definitions of the same thing. So let's have post your discussions early, give your fellow peers a chance to respond. And then there's Lab 1, implementing access controls in Windows Active Directory. Lab's pretty good in this class. I think you'll like them, but like I said, they are focused on Windows. And, so just as an FYI, as you go through. So looking at our slideshow presentation, building. So security strategies, Windows platforms and applications. Microsoft Windows and threat landscape, like I said, is the first chapter. And our learning objectives include describe information system security and the inherent security features of the Microsoft Windows operating system, and describe the threats to Microsoft Windows and applications. And like I said, this can be really any operating system and any application. The threat landscape is always changing, and I can tell you, I work in a network operating center, and we do an e-commerce site, and we're literally being hit, over 3,000 times a day with attacks that we stop from entering our network. So some key concepts. I said we're going to go over the CIA Triad and information system security. We'll look at Microsoft Windows and typical IT infrastructure. We'll look at vulnerabilities in Microsoft Windows systems and their applications. And information security, system security. So one of the things is a defense in depth, or what we call a layered approach. And it's a collection of strategies to make the computer information environment safe. And the reason why we do this, we want to stop attacks at the outermost layer, but we do want to have multiple layers. Starting with our developers, we want to have security built into the code. We want to have access controls. We want to have application firewalls. We want to have firewalls within our network, so we have multiple lines of defense. The main goal is to prevent loss, and we do have to require balance between security and usability. And so, of course, the most secure system is one that's not online, but that does not provide, any usability. And same thing with e-commerce. How can you have an e-commerce site that's totally locked down where no one can access it? Of course, you wouldn't have any sales, and so the public has to access that. Now, if you're in a company and you have a HR system, you can control access much more stringently, by just letting your employees access it. So security controls are mechanisms used to protect information. And I do have a couple videos I'll show you. One here on defense in depth. So we'll bring that up. And a quick video. So try to expand a little bit on the videos. And
if you're not making $158,000 per year, but you'd like to,
Have you ever watched a movie where soldiers are storming a castle? They may have to pass over a moat or rampart. Then they would need to find a way through or over the curtain wall. All the while, the invaders would be under attack from soldiers in the battlements. And even if they got that far, they still need to get into the interior of the castle, which involves more walls, towers, and soldiers. Castles were so difficult to attack because they had several layers of security. Compromising one layer alone does not win the day. There are threats to every system, and several ways an attacker may try to exploit them. When we consider how to secure a system, we need to consider defense in depth. The defense in depth principle states that there is no one or even two things that will completely secure a system. The point of this is that if one part of the security solution were to fail, then another part should be able to resist the attack. In practice, this means applying security in layers. For example, we could have a firewall and maybe an IPS on the edge of the network. Behind the firewall, there may be an email scanning service, and on the workstation, there would be antivirus software. An attacker may try to send some malicious code through email. The firewall and IPS may not pick this up, as email is a valid application. So, we'd rely on the email scanner. But what if that were down for some reason? Maybe it crashed, or maybe it just didn't pick up that this email is a threat. In that case, we still have the antivirus software on the workstation to fall back on. This is an oversimplified example, but you can see that using the defense in-depth strategy reduces the risk of a successful and possibly very expensive security breach. A common security mistake is to rely too heavily on the firewall. All too often people think, I have a firewall, so I'm secure. Unfortunately, that's just not true. Firewalls are only a piece of the much larger puzzle. Consider this. A simple firewall uses IP addresses and ports to allow or deny traffic. You may want to allow web browsing on the network, but is all web browsing traffic secure? An advanced firewall will take it a step further. It can do things like stateful inspection, where it determines if a packet is part of a valid flow of traffic, or whether an attacker is trying to slip a packet into the middle of a conversation. An IPS can take this even further and look deeply into the traffic to see if it matches known patterns of attacks. And still, this is just the edge of the network. What about encrypting traffic with HTTPS? Requiring authentication and authorization before accessing secure resources. New security flaws are found regularly. Are you patching these flaws in your systems? And of course, we need to consider our endpoints. That's workstations, laptops, phones, and any other device that connects to the network. This is where we think about antivirus, host-based firewalls, and VPN connections. But we can't consider something to be reasonably secured without considering all aspects of the system. We often think about technical controls like firewalls and antivirus, but what about physical and administrative controls? We need to consider things like the security of the building, locking the door to the server room, and putting equipment in locked racks or cabinets. And what about administrative controls? These relate to policies and procedures, things like background checks for staff, identifying the proper way to handle data, and so on. A big part of this is simply educating the users. teach them to use strong passwords, how to avoid social engineering, and how to recognise threats in general. This is by no means a comprehensive list of everything you need to think about. The key point to take away from this is that security should be applied in layers, and these layers are more than just technical controls. You should think about what would happen if a particular layer were to fail, and if it does, are there any other layers there to back it up? Don't leave security to chance. A big thank you to all the supporters of this channel. You help to make videos like this one possible.
Okay, yeah, so you can see, in the industry in defense in depth, our layered approach is extremely, extremely important. I mean, it's just relied upon, because with sophistication of attacks is just ever increasing, and we can't rely on just a firewall. We have to have multiple locations, and he didn't even get into the coding and security. But we at the application layer, we also need security at our application layer. So let's see, next slide. So security and controls include type of control, administrative, technical, and physical. And we saw some of that in the video. Who has access? Admins have access. Users, they don't have the same type of access. We can have physical security as well. The technical, he said, we can't rely on just technical, controls. We need physical and administrative. And we should have our servers in a secure location, and type of function. We can be preventive, detective, and corrective. And we want to be preventive as possible, but we also need to detect attacks and then correct for them. And sometimes you have attacks, like I said, an attack can be catastrophic and expensive, but a lot of times attackers are testing a system. And so I can tell you that I've seen the same attack happen from an offsite location, and it's been getting more and more sophisticated over the past year. But they're basically writing a script kiddie, and they're trying to check credit cards and check for good credit cards. And at first it was all coming from the same IP address, which was real easy to detect. And then they started spoofing the IP address, but the headers and the requests were the same, so that was pretty easy to detect. And then they started, generating different headers. And so that attack, and that's just from, one group or one person, and it's gets, just as an example of how the attacks get more sophisticated. And so, one of the things we need to talk about is the CIA Triad, which is the practice of securing information with 3 tenets of information security, which is confidentiality, integrity, and availability. And so we want to ensure our information systems have integrity, and meaning that the information in the data is accurate. That's what integrity is, like you're doing the right thing, and so what you say is true. So the data inside has integrity. It has to be confidential, meaning only the people that can see the data that we want to, or the information, have access, and also availability. And so the right people have to have access to the information. And then the wrong people should not have access, but the right people need access. And so it's, the 3-legged stool. So without one of these, we're in trouble. And so, it's extremely important. And I got a video for here on the CIA Triad from IBM Technologies. Play for you. Like I said, these videos are pretty short.
When you think cybersecurity, you should think CIA. No, not those spy guys. A different kind of CIA. What I mean is confidentiality, integrity, and availability. These 3 things make up something that we call the CIA Triad. Now let's talk about those ideas in a little more detail. So first of all, confidentiality. That's the idea that says only an authorized user should be able to see particular information or access particular resources. So in order to do that, let's take an example where we've got, let's say this guy is an authorized user and he wants to be able to read this particular data. So what would we do? Well, we'd probably put in place some sort of security system, some sort of authentication, authorization, multi-factor authentication, some sort of encryption capability so that when he goes to access this, he is given access and gets it. But on the other hand, if we have an unauthorized user who wants to do the same thing, they try to get into the system and they are blocked. So that's really what confidentiality is about. It's a very simple concept. It's a lot harder to implement. A lot of times, if you look at the literature, it will refer to confidentiality as the same as privacy. But I'll say that's kind of based on an older notion of what privacy is. Now we have a more modern notion that says confidentiality really involves more things like notice and consent and the right to be forgotten and things like that. That's not really covered in this overall notion of confidentiality, but it is still very important. So confidentiality, the first of the CIA triad. How about next? Integrity. Well, integrity basically means that if I place an order for, let's say, 100 widgets, that someone can't come along later and turn that into 100,000 widgets, or 1,000,000, or change the number entirely, or delete the record entirely. In other words, the information is trustworthy. It is true to itself, is another way to think of it. So with integrity technologies, what we do is we're looking for tampering, and we're detecting that and then alerting someone so that they know that this data is no longer trustworthy. A bad guy, for instance, might try to come into a system after he's hacked it and change the log file to remove any record that he was there in the first place. That would be an integrity attack. So we need security capabilities to ensure that the system is still true to itself. And then the last part of the CIA triad is availability. In this case, it's about making sure that authorized users have access to the resources that they need when they need them. So for instance, we have authorized user here, and they want to access a particular server. So when they come, they get access as they expect. However, we could end up with a case where we have a malicious actor who comes in and floods this system with too much traffic, therefore taking it down, making it not available. We refer to this as a denial of service attack. And a denial of service attack can take a lot of different forms, but that's the basic idea, is that a bad guy is preventing a good guy from getting access to the system. So when it comes down to security, again, think CIA, not the spy guys, but the CIA triad, and use that as a checklist. Whenever you come up with a new security project, go back over the different angles of the CIA triad and say, did I cover confidentiality? Did I cover integrity attacks? Did I cover availability? And if I've got all of those things covered, then it's job finished.
All right, great. Like I said, the CIA triad is, the founding principle of all security. So you definitely need to know the CIA triad, what it stands for, what the three pillars mean, and the triad. Confidentiality is the assurance that information cannot be accessed or viewed by unauthorized users, just like it sounds. So only people that their personal information and we think of it as personal information like financial information, medical information, but the military as well, like their military plans. Even if you look at Ford's, design of their automobiles, they want to keep that information private retail companies, they say fashion retail, they don't want their competitors to get their information on, what lines they're going to come out with, how they build their products, etc. So a successful attack against confidential information enables the attacker to use their information to gain an advantage or extort compensation through threats or divulge the information. And we'll go over the ransomware attacks, I believe, in the next course. But obviously, and you can see this in companies and overseas, where they'll Well, they'll, try to get information from their competitors to figure out, what they're doing, what products they're selling, et cetera. So integrity is the assurance that the information cannot be changed by unauthorized users. And so that is that the data information is accurate and intact. And ensuring integrity means applying controls that prohibit unauthorized changes to the information. Uh, Examples are security classification and user clearance. And so, you know, if we had access to Amazon, we could go in there and change the price of a air conditioner from a couple $100 to $20, and order them. So, we want that data to be accurate. And of course, all our information systems, integrity is extremely important. And then availability is assurance that the information is available to authorized users in an acceptable time frame when the information is requested as availability. And what is that requested time frame? I would say, it's almost instantaneous or immediate now. But examples of attacks that affect availability or denial of service, and then hacktivists. Denial of service does happen frequently. One of the reasons you don't hear about it as much because web application firewalls are very good at spotting this type of attack. You're monitoring your network, and say you get 10,000 requests, every minute, and then all of a sudden you go from 10,000 to 15,000, 20,000 to 30,000. Then the WAF is usually pretty good. Because like I said, there's something with the traffic that's similar. So it can be coming from the same country, it can be coming from the same region, it came from the same user, the same set of users, and so it can get, more and more sophisticated, but our WAFs pick it up, much better than it did, 15 years ago or even 10 years ago. So Microsoft Windows and applications in a typical IT infrastructure is IT infrastructure is a collection of computers, devices, and network components that make up the whole IT environment. Like I said, typically in a company, small, medium-sized company, may be completely on a Windows platform, but there's probably at least, people that, really like their Macintoshes. And so, you may have some Mac laptops, you may have Unix servers or Linux servers, Cisco routers. There's the infrastructure is anything that you can physically touch in your IoT environment. And a lot of people say it's the cabling as well, that connect the network. Continued. So common components are our client platforms, our laptops. They can be our phones, they can be tablets, our network segments, or network devices. Like I said, like routers and hubs, our server instances, and often listed by function. So servers, you can go out, you can buy a server, but a server is really performing a service. And so that's what they're saying. So, you can have a mail server, you can have a print server, they can actually be on the same machine, but the server is serving mail or is doing the service of providing a mail or providing print. You can have a file server, where people can save things. And we can also have cloud-based office such as Microsoft Office 365 and Microsoft Azure. Like I said, most companies are using Microsoft Azure and Office 365. You can also use Google, but Azure is doing a really great job with the SSO, and providing the LDAP services, which we'll go over later, which is basically, how you do access control. So I do have a short video on this, actually from Microsoft, because Microsoft Azure is, like I said, is extremely important. And I think, at least your medium to large size companies, you probably have something in Azure, because they're just doing a great job with their.
What is Azure? Azure is Microsoft's cloud computing platform with an ever-expanding set of services to help you build solutions to meet your business goals. Azure supports infrastructure, platform, and software as a service computing with services such as virtual machines running in the cloud, website and database hosting, and advanced computing services like artificial intelligence, machine learning, and IoT. Most of Azure's services are pay-as-you-go. You only pay for the computing time that you use. If your business needs complete control over your computing environment, Azure allows you to host virtual machines in the cloud. You can create virtual machines from scratch, upload your own virtual hard drive, or choose from an array of templates that Azure provides. Azure also provides cloud-based storage, which allows you to store your application or backup data safely and securely. Azure's app services provide a scalable hosting platform where developers can create web-based applications using popular development frameworks. You can easily deploy, operate, and scale your apps in a fully managed environment. With Azure Functions, you can create event-driven, serverless applications with no coding required. Azure Container Instances and Azure Kubernetes Service allow you to deploy containerized applications with fully managed services. Azure offers a choice of fully managed relational and in-memory databases, spanning proprietary and open-source engines, and Microsoft's Cosmos DB provides support for several popular NoSQL APIs. Azure's artificial intelligence and machine learning services empower developers and data scientists with a wide range of productive experiences for building, training, and deploying machine learning models faster. Azure's regional data centers allow you to distribute your applications globally, so you can locate your data and apps where they're needed most, thereby improving your application performance for your customers. The Azure portal lets you create, configure, and control all your services and resources from a single, easy-to-use web-based interface. Microsoft Azure offers a wide array of cloud computing services where infrastructure management, scalability, availability, and security are handled for you, saving you time and money.
So you can see, Microsoft Azure does Azure does quite a bit, and more than just offering Office 365, but that is one of the applications they offer. And like I said, I would say most companies are using Office 365, if not Google. Most medium to large companies now, and they it's not that you're tied to use only that. Where I work, we also use Google. We use Google Cloud and Azure as well, and so and we use AWS as well. So AWS, they're probably the top three, and we use actually all three of them, and we do on-prem stuff. And so here's a sample IT infrastructure, and you can see that we have our local area network or intranet, and we have a DSP server, some health requirements. So this is probably some kind of medical company, but health requirement servers or health registration authority. We got IEEE devices, our LDEP or Active Directory, and an RIP servers, and then we got our VPN to front end it, and then we got our edge network, our perimeter network, and then we have restricted networks with NAP clients with limited access. Our Windows clients, thinking about our laptops and our tablets, their client systems provide functionality. End users, customer-facing systems include our desktops, laptops, and mobile devices. Each application will be deployed on the client system to either a thin or thick client, and Windows 10 is the latest client operating. So again, these can be Mac devices. You don't see too many Linux devices, but you are going to have Mac as well, or Apple. You're going to have Apple phones, and it's and more people are using the mobile devices or their mobile phones, and a thin or a thick client is just how many resources that machine has. So like you're thinking of a real thin client like AWS or Amazon, provides different tablets. I think they have like a $79 tablet out now, and but it's a pretty thin client, where you store most of your files and things on the cloud. It doesn't have very much local storage. where a thick client could be a much more robust machine that maybe developers want to have. Windows servers or server computers that provide services, clients, applications. There's web servers, application servers, and database servers, are probably the three most common applications. And servers are essentials for all businesses. Then we can have a data center where we keep our large scale deployments, or where we keep these servers, or they could be in the cloud as well. So you can have, your Windows servers in the cloud at one, like Azure or Google or AWS, and still maintain those through infrastructure as a service. The EULA, or the Microsoft End User Agreement, is a software license agreement that contains the Microsoft software license terms. Must be accepted prior to installation, and it's located in the Windows install folder on the Microsoft website. And so definitely getting certified, security, and in Microsoft specifically, there'll be questions on the EULA. And let's see. So the sections include updates, additional notices such as networks, data, and internet usage, limited warranty, and exclusions from the warranty. Threats and vulnerabilities, like I said at the beginning of the introduction, we'll also go over threats and vulnerabilities. So a successful attack is that one that realizes carries out a threat against vulnerabilities. And again, just a successful attack, they can be just trying to gain information, that they can use for competitive reasons. They can try to do a denial of service. But three big concepts are: the risk is any exposure to a threat. A threat is any action that could lead to damage, disruption, or loss. And a vulnerability is a weakness in the operating system or the application software. You could add network in there as well. So Windows threat vulnerabilities, the threat is not necessarily dangerous. Like I said, a fire in a fireplace is desirable, and the data center is dangerous. For damage to occur, there has to be a threat. Attackers look for vulnerabilities and devise an attack that will exploit the weakness. So they're always, hackers or attackers are always checking for weaknesses. I did say we go over ransomware, and that is the malicious software that renders files or volumes inaccessible through encryption. The attacker demands payment using cryptocurrency or description key. Well-known ransomware attacks are like CryptoLocker, Locky, and WannaCry. And I did have a short video on that as well. And I'll try to put these links in an announcement so you can check these out as well if you want to watch them. Let's see. Like I said, with the discussions, I encourage you to, do some research and bring in, more information.
I've
like
seen
I'm
your
doing with
family
these videos.
photos, the weddings, the vacations, your financial information. I've got it all. It's fabulous stuff. And if you ever want to see it again, you're going to pay me big. So how do you make sure that doesn't happen to you? Well, preparedness is important. What I was referring to in that attack is something called ransomware. And in a ransomware attack, your data is sitting out here on some device. And the attacker then is going to encrypt all of your data and make it so you can't see it anymore. And then they're going to say, if you want to see it, it's going to cost you. That's the ransomware attack. And there's really two different variations when it comes to data with regards to ransomware. One of those is the attack that says, I've got your data and I'm not going to give it back. So what could we do in that case? This is a case of data loss. And then the other type is, I've got your data and I'm about to give it to the world. So this is a breach. This is where we're going to say your information is about to be released. Now, either one of these could be devastating. It just depends on what it is that you're most concerned about and what it is the attacker is trying to do to you. In the case of data loss, the best prevention is a backup. If you have got a solid backup of all of your data, then when the attacker says, pay me or you don't see this again, you just say, get lost, because I'm going to recover from my backup. If the case is, I've got your data and I'm about to release it to the world, well, now we've got to do something different because the backup won't prevent that from happening. What could we do in those cases? Well, one of the things we need to do is make sure we have strong access controls. I talked about this idea of multi-factor authentication in a previous video. We want to make sure that only the right people have access to this information, so the ransomware attacker doesn't have access. Another big thing I can do is an insurance policy of encrypting the data. Encrypting this will allow me to make sure that even if someone has the information, they can't do anything with it. They can't read it. They can't release it. If I encrypted it and I did a good job of that, then it's still secure. Those are the two main types of attacks, and these are things that you should do now before you get the ransomware message. Once you get the ransomware message, it's too late to do these things and make a difference. Then we could have a discussion about whether you pay the ransom or not, and we may discuss that in a future video. Another thing that you should do to prevent in all of these attacks is do things like patch your systems. Make sure that you have all the latest software fixes on your system. I know it's not fun. Here comes out a new update of the software on your phone, on your laptop, what have you. If you don't have it, the chances are you've left the door wide open for an attacker. You could also add things like antivirus or endpoint detection and response capabilities. These sit on the device, depending on the type of device, and will detect ransomware attacks and block them in many cases. And then finally, a big point of this, if you're looking at this for an organization, is end user training. The most common way that ransomware gets spread is it's through an attachment in an email or something similar to that. We still have to be vigilant and remind people, don't click on everything that comes to you in an email. And the ransomware attackers are getting better and better and more convincing at why you should click on that. So we've got to stop that. These are the defenses. So the bad news is the attack is real and it could cost you a lot. The good news is there are things you can do right now to prevent it. Thanks for watching. Please remember to like.
All right. So that's the last video, chapter 1. And did a great job. That's IBM. They do a great job on discovering. But so we need to look at the discovery, analysis, remediation cycle. I mean, so threats are ongoing, so we always have to look for new threats, discover the threats, then do analysis on it, and then finally remediate it. So what's happening? How do we stop it? You know, have they done anything as far as, you know, any kind of damage, and then remediate it as well. Make these bigger for you. So discovery, once the attack starts, the attacker becomes as inconspicuous as possible. Need to compare suspect activity to normal activity. Like I was saying that earlier, you know, if we get 10,000 requests a minute, and also we're getting 50,000 requests a minute, you know, probably our cell is not generating that much traffic. You know, of course, we can have traffic spikes such as Black Friday, you know, or the day after Thanksgiving when we're doing sales. Common method to accomplish this is through use activity and monitoring logs. Analysis, security information and event management, or SIEM tools, can collect and aggregate security-related information in multiple sources and devices and help prepare data for correlation and analysis. Current vulnerability and security bulletin databases help determine if others are experiencing the same activity. And that's, you know, one of the reasons, like I said, that you may use a web application firewall, such as a company from Akamai, because they have multiple customers. And, you know, so they're seeing the attacks across, you know, different businesses and different organizations and different SaaS companies. The remediation contain any damage that has occurred, recover from the loss, and implement security controls to prevent it from reoccurrence. So like I said, if our data is encrypted and we do have loss of data, they may not be able to do anything with that data. If they access the system that's public anyway, one of the things that happens, which is very hard to prevent, is that other companies will go onto your website and take product information. You could go on Amazon and start downloading product information of the products that are being sold on Amazon and try to create your own. You would know the price points, you would know what products were, you wouldn't know how to build them, but that is a loss of information. Common form of attacks. Phishing generally start with a message that contains a link or an image to click or a file to open, and it usually launches a malware attack, and also can do that's one of the avenues for ransomware. Malware is the malicious software designed to carry out tasks that a user would normally allow. Denial of service is any action that dramatically slows down or blocks access to one or more resources. And an injection attack depends on the ability to send instructions to an application that causes the application to carry out unintended actions. The SQL injection is one of the most common application and attacks. And we definitely need to check applications for that because it's very easy to do and very common. We have unprotected Windows share. Situation allows attackers to install tools, including this software. Session hijacking and credential reuse. Attempts by attackers to take over valid sessions, capture credentials to impersonate valid users. And so again, like on a public e-commerce site, once you enter Amazon or another sell site, you set up a session and that's how they know you are. And then you're logged into that session. And so somebody could possibly get your session ID and then, and then order products, with your banking information. Cross-site scripting is specifically crafted malicious code used to attack web applications. Very common. Again, packet sniffing is process collecting network messages to travel across the network to try to gain sensitive information such as passwords. And so they don't halt the information going, they just copy it and then see it. So in summary, we talked about information security, system security in the CIA Triad. Make sure you know the CIA Triad, which each part of the Triad stands for or means. We looked at Microsoft Windows and typical IT infrastructure. And again, you can have other OS systems in there. And then we looked at vulnerabilities to Microsoft Windows systems and their applications. And also this week, we're going to go over chapter 2. Let's see, I got that up, I believe, yes. And so chapter 2 is security in the Microsoft Windows operating system. And the learning objective is to describe information system security and inherent security features in the Microsoft Windows operating system. Key concepts include basic Microsoft Windows operating system architecture, Microsoft systems application vulnerabilities, the purpose of access controls, authentication and permissions, and the Windows attack services and mitigation. So the operating system components and architecture. For the operating system, we have a collection of many programs working together along with the data to provide access to physical resources. And the goal of secure information is all required information is available to all authorized users. And then, of course, no information is available to unauthorized users. So the right people or the authorized people are allowed to access it. So the first step in planning how to secure operating system is to understand the purpose of the kernel and the operating system components, which we'll go over. So the operating system kernel, we have our applications. We have the kernel that talks to the applications and the hardware. And I do have a video on this, but the kernel is part of the operating system, or kind of the heart of the operating system. And it's and it, kind of, people say like it's the traffic cop that goes between the applications and the actual hardware. We create a layer between the applications and all the devices and the memory and the CPU. We bring up that Tech Quickie video. A little bit of animation may help understand it.
At Alienware, we're always working to improve how you experience your favorite games.
When you hear the word kernel, you might think of popcorn, chicken, or popcorn chicken, or the Colonel's popcorn chicken. But you might have also come across the same word in a computing context, with folks talking about the Linux kernel or Windows kernel. What the heck is it? The kernel is basically the heart of whatever operating system you're using. Although the kernel is a software component, it sits between your system's hardware and the rest of your OS and software. You see, user software such as your web browser or your favorite game doesn't talk directly to your hardware. Instead, the kernel serves as an intermediary. But why is this necessary? Well, one of the main functions of a kernel is to abstract away the physical differences between hardware setups. There are an endless number of possible hardware configurations in a PC or server. I mean, think of how many rigs you could build just from PC part picker lists. A kernel gives your other software a standardized surface area to interface with, making the differences between individual machines much less of an obstacle. As a more easily digestible analogy, kernels provide the low-level plumbing that your software hooks into. The pipes underneath your house might not be all that interesting, but they allow you to make tons of choices as to what you're gonna hook them up to, without caring whether it's a dishwasher, a jacuzzi, or that cool RGB shower head you found on Amazon. What, like I'm gonna see that and just ignore it? Another key function of the kernel is to provide security and stability. Allowing programs to talk to hardware in any way they wanted could allow them to access data they aren't supposed to, which could lead to a system crash or data theft from a malicious process. But because programs have to interface with the system through the kernel can prevent these sorts of shenanigans. If you've ever heard the term protected memory space, this is part of what we're talking about. Running programs get their own portion of RAM and can't access memory outside of that thanks to the kernel. But of course, plenty of things can still go wrong. We'll tell you how and how kernels have been designed to prevent crashes right after we thank our sponsor, Odoo. If you're looking to create a website but lack the technical expertise, Odoo is here to help. Building a website is quick and painless with Odoo's open source intuitive platform. Use simple yet comprehensive drag and drop elements to make an eye-catching and engaging page for your audience to interact with, all with no coding experience required. They've also recently introduced their own AI copywriter powered by ChatGPT. So if you find yourself at a loss for words, you can let AI are designed in one of two main ways. Monolithic, meaning the kernel incorporates most of the main functions of the whole operating system, and microkernel, in which the kernel handles more basic functionality, leaving more software such as device drivers running outside of the kernel. Monolithic kernels tend to be higher performance and easier for programmers to work with, while microkernels have the advantage of being able to kill problematic processes without bringing down the whole system. Now, the Windows kernel was designed to be more of a microkernel, while the Linux kernel was more monolithic. But these days, both operating systems have moved towards a hybrid kernel model to try and incorporate the advantages of both design philosophies. For example, Linux is commonly found on servers that need as much uptime as possible. In other words, you don't want to reboot the whole system if there's an issue, so it makes sense that Linux has moved away from being more purely monolithic and has tried to become more modular. Meanwhile, in Windows land, gamers benefit from the OS adopting a more monolithic philosophy that doesn't have as much overhead, enabling higher performance for folks who are trying to squeeze as many frames as possible out of their rigs. Picture orange juice, but much less tasty. Of course, no matter how you design a kernel, crashes can and do happen. If you've ever heard the term kernel panic, this means the system has entered some kind of unstable or undefined state, and the kernel decides to just halt the system as the OS simply doesn't know what to do next. This is what often causes Windows blue screens. It's not because your computer hates you. But why can't the system, just fix itself instead of needing a reboot? Well, error handling functionality in an OS like Windows has to be written for specific errors. So if the system encounters an error it wasn't written to handle, you'll likely get a kernel panic. But one example of an error the Windows kernel is designed to handle is when your display driver crashes. You know how your screen goes blank, then it comes back up, and you get a little notification saying the driver successfully recovered? That's a bit of kernel magic that took the developers a great deal of effort to write. So remember that when you get a blue screen, please know your poor kernel is trying its hardest. It just has no idea what to do next. I mean, you wouldn't get mad at your dog for not being able to speak German right, unless it's a German Shepherd, in which case, jail. And you're definitely not going to jail because you watched this whole video. Wow, thanks so much. Hey, like the video if you liked it, dislike it if you disliked it. Check out our other videos.
All right, let's see. So let's see I'll move it on past the kernel, looking at the Windows process table contents. So you'll do this during the lab. You'll bring up the process table, and you can see, all the apps that is running on this Windows machine, including Chrome and Outlook, Task Manager, and that is running right here, and then background processes. And so the kernel, is manage all this. And one way to look at it is through a process or task table. So the operating system components, the kernel provides core services. So the operating system calls external programs to provide many more operating system services. Operating system is a collection of programs that control access to the physical hardware. Information is stored and transmitted on the physical hardware. And ensuring security on protected information starts with ensuring security on the operating system. Some of the components include program or process management, where the OS manages locating, loading, and executing programs, handles memory allocation, CPU scheduling, and providing an environment for programs. Input and output. The OS hides details of the physical hardware and provides programs with ability to process I/O. The file system, the OS provides access to long-term storage and helps to organize information to make it easily and efficiently accessible. Communication, the OS provides support for exchanging information between programs locally and through the network or with other computers. Error detection and alerts, the OS monitors activities that occur within the computer and responds when an error occurs. So the basic Windows operating system architecture, current versions of client server Windows are based on the Windows NT. There used to be the FAT code base, but now they use the NT code base. And like you said, it's a modified microkernel architecture. Windows, Linux, now the OSs are getting a little bit closer, but still Linux is more monolithic. Because of the modular nature of Windows, major components can be removed, replaced, or enhanced without having to rewrite the entire operating system. You'll see this in server, where you can add and remove different things like being a print server or a mail server, which comes, as components of the operating system. So looking at Windows run modes, different concept, we'll go over the kernel mode or supervisor mode and user mode. And so those are the two main modes. So the kernel mode is a privilege mode. It's called either kernel or supervisor, and it allows us to interact closely with the physical hardware. Most time we want to run our OSs in user mode to interact with our users and the kernel mode programs. And video on this. Let's see. Link up.
So what is ClickUp? ClickUp is an all-in-one productivity software where you can manage everything and anything.
Let's skip those quick.
Hi there. Welcome to MCSI. My name is Rosie. In this video, I will give you an introduction to Windows User Mode and Kernel Mode. In this series of videos, we will discuss some fundamental concepts about the Windows operating system that will be useful in malware reverse engineering and vulnerability research. Windows OS functions in two modes, the user mode and kernel mode. User applications run in the user mode. This includes applications like Paint, Word, web browsers, services like FTP and SSH, features like Windows Subsystem for Linux, and some system processes like the Session Manager. Critical operating system applications run in the kernel mode. This includes the main OS kernel, programs responsible for core functionality like process and thread management, memory management and networking, system drivers, and programs responsible for system-wide graphics. Programs running in kernel mode have higher privileges than programs running in user mode. Kernel mode programs have unrestricted access to all system resources. User mode programs are given privileges required for their functioning. A program running in user mode uses system calls to switch to kernel mode. I'll tell you about a scenario where Windows switches between these two operating modes. Here is a text file. I am logged in as user 10. I want to open this file and read it. Currently, the OS is functioning in user mode. When I double-click this file to view its contents, Windows would send out some system calls to drivers operating in kernel mode and prompt them to read the file from the hard disk. As the file is being read from the hard disk, Windows switches to and functions in kernel mode. Once the read operation is complete, it switches back to user mode. All this happens in the background without the user noticing. Windows uses special APIs to interoperate between both modes. Are you wondering why we need to know about Windows operating modes for malware reverse engineering? Most malware begins to execute in user mode. Using APIs, it may attempt to switch to kernel mode to gain access to the entire system. Reversing the sample would help detect the use of those APIs. Some malicious samples, like rootkits, are designed to operate entirely in the kernel mode. Such malware would give an adversary complete access to the system. When a reverse engineer is aware of the different OS operating modes and how programs behave in these modes, it would help to understand malicious code better. User mode and kernel mode are also referred to as user land and kernel land, respectively. I hope you have a good idea now about the operating modes of Windows. Stay tuned to our channel for more videos on Windows.
Right. Where were we? So the Windows operating system, you can see that the user mode, connects to the integral subsystem, environment subsystem, go through executive, and then the kernel mode connects to the kernel mode drivers, to the microkernel, and it goes down to the HAL hardware extraction level and actually connects to the hardware. Programs running kernel mode had complete access to computers, hardware, and services needed by the operating system and provides an attractive target for attackers. That's one of the reasons why we want to use the HAL. I use kernel mode drivers, the microkernel, and executive. Let's see. User mode is a non-kernel mode. Programs run under user mode. Most of our applications run on user mode. And it handles user interactions and processing requests and pass IO requests to the necessary kernel mode drivers using the executive. Main user mode program components include the environment subsystem, provides ability to run programs written for different operating systems, including Windows and Linux, and an integral subsystem handles user mode functions on behalf of the environment subsystem, including logon, access control, network access, and providing network services. So looking at access controls and authentication, which is, of course, extremely important for security. Access control is process of providing and denying access. It's a multi-step process, starting with identification and authentication. And regardless of the methods used, operating systems need to identify a user asking for access to a resource. And usually, in the Windows world, that's through a username or a user ID. And so the authentication system collects identification credentials such as username, collects authentication credentials such as the password, finds the storage information supplied, and then compares it with the database, and then if they match, the user authenticated. And then much, I wouldn't say strongest, but the stronger is to use two-factor authentication or multi-factor authentication. We'll go over the different factors, but they can be like a random number generator, a text to your phone. And you can see most financial systems and many systems have two-factor authentication now, but different authentication types. You can have which is your password and your user ID and a PIN. What you have, which is the token or a smart card, some kind of random number generator, and then what you are. So we can use fingerprints, handprints, or retina characteristics. So of course, if you did all three of these, that would be more secure than only doing one, and then of course only doing two factors. So if you do three factors, it's going to be more secure. So access control methods, we have discretionary access, mandatory access, and role-based access control. Role-based access control is good, of course, frequently used. And I have a video on this from Get Safe and Sound over the different models. Bring up.
Most people have no clue that in 2023, the best way to make money on Amazon is not with...
Do you know the 4 main types of access control models, including a new type that has been gaining popularity lately? Well, keep watching and you will. I'm Jorge Ramirez with Safe and Sound Security, the place where professionals turn for security system information and solutions. Today, we're going to talk about the 4 main types of access control models. When you own a business, it's important for you to be able to grant access at different levels to different people in your organization. Access control models are an invaluable method of gatekeeping for organizations of all sizes and backgrounds. The 4 types of access control models allow you to control everyone's access, and each type of system has its own pros and cons. Today, we're going to provide an overview of the 4 main types so you can make an informed decision for your business. Keep watching to learn more. Here are the 4 most common access control models: mandatory access control, discretionary access control, role-based access control, and rules-based access control. The first type, mandatory access control, is the most restrictive form of the 4 access control models. It gives control and management of the system and access points to only the system owner or administrator. End users and employees have no control over permissions or access and can only access the points granted to them by the system owner. Even the owner is restricted by the system's parameters, which are programmed as such and cannot be circumvented. All users are classified and labeled according to their permissions, and they receive permissions to enter, access, and exit certain points according only to their specified classification level. If the system owner wishes to grant higher level access to a user, they usually need to create a new profile and credential for that user. Their previous classification cannot be given any permissions not already specified in their profile. This type of access control is most beneficial for facilities and organizations where maximum security and restriction are required, such as military and government facilities. It's also used in corporations where security and secrecy are highly valued. The next type of access control model is discretionary access control, and it's the least restricted of the 4 methods. It allows the owner or administrator of the system complete control over who has access and permissions throughout the system. It often runs off common operating systems, such as Windows, and is generally easy to configure and control. One main benefit of discretionary access control is that the administrator can easily and quickly configure permissions, deciding who gets in, when, and where. A downside, however, is that this often gives too much authority to the administrator of the list. There is a potential for them to pass access onto inappropriate users. It also leaves the system vulnerable to malware, such as Trojan horses, which can infiltrate the system without the user's knowledge. Role-based access control is the third traditional type of control, and it's one of the most popular. It's sometimes referred to as RBAC or non-discretionary access control. RBAC assigns permission based on the position or role a user holds within the organization, and these predefined roles hold the appropriate permissions. For example, if a user is classified as a project engineer, they will automatically receive the permissions entitled to all project engineers within the system. The benefit to this access control model is that it is quite simple to set up and use, especially for the system owner or administrator, who simply has to set up predefined roles with appropriate permissions. A drawback, however, is that if a user needs permissions they do not have, the administrator needs to grant them permission outside their predefined role. Depending on the case, this may or may not be possible. RBAC is a great option for cloud-based access control systems where the rules and permissions between users tend to be more dynamic. The final type of access control is the one I teased at the beginning that has been gaining popularity lately: rule-based access control. Rule-based access control allows system owners and administrators to set rules and limitations on permissions as needed. For example, they might restrict access during certain times of day, require a user to be in a certain location, or limit access based on the device being used. Permissions can even be determined based on the number of previous access attempts, last performed action, and required action. This access control model is good for enforcing accountability and controlling when and where employees have access to certain facilities. It's very beneficial because permissions and rules can be dynamic, allowing the system administrator to customize them for any number of situations and needs that may arise. Permissions can be determined in any combination of criteria, allowing for countless configurations for almost any number of unique situations. It's also great for multi-door access controls where users may be restricted regarding which doors they can access. Now that you know more about the different types of access control systems as well as their benefits and drawbacks, you should have a better idea of what type of system is best for your organization. If you'd like to browse some
So role-based access control. Yeah, I mean, that's one of the reasons why it's so popular is because we can put all the HR people into a role. We can put all these salespeople into a role, and then we're not managing that per person. We're managing it based on the role that they play in the organization. So token rights and permission, each local user and group in Windows has a unique security ID. I'll show you that real quick. And so you can bring up your command prompt and you can type in who am I? And it'll show you, who you are, what your name is. But if you do who am I/user, it actually shows you your SID. And so it shows you your username and then also the SID. And so the SID is what's tied to, what role you have and what access you have. So when the user logs on, it fetches the user's SID and the SID for groups which the user is assigned. It looks up the local rights for your computer that you're on, and then all SIDs and local rights are linked to an ID object called the security access token. Then under our computer management tool, if you go to, you have users and groups, and you can see the different groups that you can be assigned to. And then access rules, you have user rights, actions a user is permitted to carry out. Permissions are defined what a user can do in a specific object, such as read, write, delete, execute. Access control list stores access rules or permissions for resources for the objects. Users, groups, and Active Directory. Computer environments becoming more diverse and geographically separated, but still integrate using networks. So Windows environments become more dependent on internally and externally shared resources. So at work, you're not just working on your own laptop, you're connecting to different shares and requesting, things from servers. Work groups or peer-to-peer networks allow Windows computers to share resources. This is more for your small business. Say you have a real estate company with 8 laptops or 8 computers, connecting maybe some Windows or Apple and Windows phones as well. Users group must be defined on each computer. Every change to security permission must be applied to every computer. administration work groups with more than a half dozen computers become more difficult, like I said. So that's work groups are for, mainly smaller companies. Then we move to the Active Directory, allows users and groups to be found at a central location and shared among multiple computers. And definitely we have a network operating system. We're using some kind of LDAP. Can define limits on how many computers share users and groups by defining domains. Domain is a group of computers that can group together for some purpose. Ability to define and identify authorization permission can be shared among multiple computers with one or more domains. Reduces redundant administrative effort and requires additional administrative time resources than work groups. And I believe this is the last video for this week, but I did want to show you Azure Active Directory. So going beyond Windows Server and looking at Azure, just because, like I said, it definitely at your medium and large size companies, this is probably what you'll use for authentication.
Wow, I just built the most amazing workflow on Monday.com.
You build your own workflow? Why?
Azure Active Directory, also known as AAD, is a component of Microsoft Enterprise Mobility and Security. It provides identity and access of management to Microsoft 365 and other cloud-based and on-premises services. By creating a single identity that can be used for all devices, your security is increased, as is your control. This single identity is used as your single sign-on for multiple devices and applications. For example, you could log onto your company's CRM, your emails and intranet, all with one set of credentials. Employees can sign into almost any service regardless of device model, location or user identity, including both cloud software and on-premises software. With one password, users can access pretty much everything. So how does this improve your security? When each user has a single unique identity, it allows for conditional access. So you can block or allow users to log on to certain devices, services or apps based on various factors. A key feature in Azure Active Directory is conditional access, which includes multi-factor authentication to verify the user's identity, ensuring the actual logon is secured. And finally, having secure identities allows for reporting on logins and visibility of the data associated with the access requests. As we move into a digital world, it is essential for employees to be able to work with the ease and security of single sign-on that Azure Active Directory provides.
All right. Like I said, that's the last one. Probably just a few more slides. So Windows attack surfaces mitigation, operating system services expose part of the computer to the external access. There's always a risk involved. Vulnerabilities, again, are weaknesses that can allow unauthorized access to if successfully exploited. And our attack surface is the total collection of vulnerabilities that could provide unauthorized access to our resources. So again, we want to use multi-layer defense or defense in depth. You can see that you have the firewall. We have our access control, encryption, and then finally we have our resource. So if we have an attack, it has to go through multi-layer. So we want to try to prevent it at the outermost layer because we don't want them to get inside our network. But we do want to use multi-layers in case these two layers fell. We want to have as many layers as possible. And mitigation is to remove vulnerabilities and stop attacks from exploiting vulnerabilities. Fundamentals of Windows security monitoring and maintenance. Points in the system lifecycle that serve as milestones include install the operating system or application software, monitor the operation of the computer system, and make configuration changes to computer system. And typically with our server environment, we're doing server patching at least once a month. And then of course, with your own machines, you can see that you also have updates. Windows has updates. Security monitoring, identifying vulnerabilities. Monitoring includes define security goals, describe security behavior as a baseline, sample performance information, compare with baseline, reporting the anomalies, vulnerabilities, including identifying them, and then making a plan to address each. So in summary, we talked about the basic Microsoft Windows operating system architecture. We looked at Windows system and application vulnerabilities. We looked at the purpose, access controls, authentication and permissions, and we looked at the Windows attack services and mitigation. And so that's the PowerPoint for this week. Like I said, you know, the Lab 1 will be implementing access controls in Windows Active Directory, so you'll get some experience with the Active Directory. If you have any questions, feel free to email me. I look forward to our discussions this week. And you know, have a great week. Make sure get your assignments in on time. And like I said, if you have any questions, just shoot me an email. Usually respond the same day, but not the next day, depending on what time it is. Thank you so much for your time.